we're going to see how we can find conjugates and rationalize denominators. Now, in order for us to rationalize the denominator, we first need to know what is the idea of a conjugate. Now, let's start by finding conjugates for the following expression. To find the conjugate, you're going to look at your expression and you're just going to change the sign. So, the conjugate of square root of 5 minus 6, it's going to be square root of 5 plus 6. You basically just change the number. So the conjugate of any expression, well, not any expression, but just an expression that has two terms, or a binomial expression, you just change the sign. That's pretty much it. That's what the idea of a conjugate is. It looks straightforward, but that's a powerful idea when we try to rationalize the denominator, which we will show in the next slide. So here, the conjugate is equal to 2. If you see a plus, you change it to a minus square root of 3. And that's it. This is how you find the conjugate. You just change the sign. Now lastly, what is the conjugate? Oops. So with my well, you can read it. Conjugate. The conjugate of the fixed expression is just 4 square root of 5 minus 5. That's pretty much it. Nothing fancy here. Now let's use this idea of conjugate to rationalize the denominator, which is the main idea of today. Now, it is an expression. First, let's start with something simple. Now, the whole idea of rationalizing the denominator is to get rid of the square root in the denominator. When you have an expression and you have a square root in the denominator, we don't like that. So somehow you need to get rid of the square root. Now let's start with the idea of how do I get rid of this square root when there's only one term on the denominator. So we usually multiply by the conjugate, but when there's just one square root, we just multiply by that square root. So to rationalize the denominator of this expression, which only has one term, what we do is we multiply by the square root that I want to get rid of, top and bottom. I see that I need to get rid of the square root of 6. Well, I multiply square root of 6 top and bottom. And you will see what happens there. Now, from our previous lesson, we're going to multiply. Now you got to remember that here, what we're doing is basically just multiplying. We're just multiplying fractions here. So as a side note, how do you multiply fractions? Top, top, bottom, bottom. So that becomes 12. 3 times 4, that's 12. 2 times 5, that's 10. Okay, so you can simplify this. So we're going to apply the same idea here. We're multiplying fractions. This is a fraction, this is a fraction. So we follow the multiplication of fractions. So we're going to multiply the top with the top and the bottom with the bottom. So multiply this. And now from our previous lesson, we have 3 times x inside minus 9 square root of 6. Because when you multiply two square roots, you multiply the inside. If you multiply by a number, you just put them next to each other. So that's it for the numerator. So now let's divide the denominator. So now here we're going to have, let's put it in a different color. The 2 stays out. Multiply the inside, square root of 6 times square root of 6. So 6 times 6. So now let's simplify this. 3 times 6, that's square root of 18. Minus 9 square root of 6. Divided by 2, square root of 36. Now let's see, can I simplify anything? I see that, oops, let's erase this. Notice that the square root of 18, I can rewrite it as 9 times 2 But from our previous lesson, you know that 9 is a perfect number. The square root of 9 is 3, so you can rewrite it as 3. Oops. Square root of 2. You can take this 9 out because we know the square root, and that's how we got this 3. So square root of 18, we can rewrite it as 3 square root of 2 minus 9 square root of 6. 2 to square root of 36 is just 6, so we multiply by 6. And there you have it. Well, let's simplify this. 3 square root of 2 minus 9 square root of 6 over 2 times 6 as 12. This is the rational version of our initial. Notice our final answer does not have a square root on the denominator. We do not want a square root on the denominator. So if you have a square root, this is the process. Okay? You multiply by the square root, top and bottom, of what is it that you want to get rid of, which in this case was square root of 6. You multiply multiplication, and then you simplify. Now, let's look at when do we have, well, we have a square root in the denominator. We certainly don't want that. But now, we don't have just one term, like we did in the first example. Now here, we have two terms on the denominator. So how do we rationalize this denominator? Well, when you have two terms, we don't multiply top and bottom by just the square root that you want to get rid of. We multiply by the conjugate of the denominator. Now, what is the conjugate of the denominator? Again, it's square root 3, and then you change the sign. Instead of a minus, it's a plus. Top and bottom, square root 3. Plus square root of 5. Now again, square root of 3 plus 5 is the conjugate of the denominator. So when you want to rationalize the denominator, when you want to get rid of a square root on the denominator, and you have two terms, you multiply by the conjugate, which is you just flip the sign, top and bottom. So now we multiply, we perform our multiplication. So now it becomes 2 times 3, so 2 square root of 3, 2 times 5, 10. Okay, so now we have our numerator. So now let's distribute our denominator. Square root of 3 times square root of 3. We have square root of 9 because we multiply the insides. So square root of 3 times 5. You leave the number aside. 5 square root of 3. So we have that. Let's multiply once again. But now let's do it in orange. Negative 5 times square root of 3. That's negative 5 square root of 3. And negative 5 times 5. That's negative 25. Okay. So now we have this. What do you notice? Look at the denominator. Look at what happens when you multiply by the conjugate. Here, the square roots cancel out. And this is exactly what we want. Because when you multiply by the conjugate, you're looking for the square roots to cancel out. And that's exactly what we have here. So when you multiply by the conjugate, the square roots will most likely will cancel out. So now that I know they cancel out, let's simplify a little bit further. So 2 square root of 3 plus 10 divided by square root of 9, that's 3. Cancel, cancel, minus 25. So now we have 2 square root of 3 plus 10. 3 minus 25, that's minus 22. You don't have a square root in the denominator anymore, so we're okay. This is exactly what we want. This is a simplified version. We do not have a square root in the denominator. This is what I wanted to get rid of, the square root. It's the same expression, but we don't have a square root anymore. Let's try that same. Another example here. Now, it doesn't matter if it's 2 square roots or 1 square root. How do you get rid of the square roots in the denominator? You multiply by the conjugate. Now, what is the conjugate? It's basically the same expression. We multiply by the conjugate on the denominator. It's the same expression, but instead of a plus, we put a minus, and you gotta put that top and bottom. Now, why is this allowed? It's because you're essentially multiplying by 1. The same expression divided by itself is 1. So you're multiplying by 1, so you're really not changing the original expression. Because any number multiplied by 1 is basically that same number. Now, let's perform our multiplication. Let's perform the multiplication on top. Square root of 15 times 5. So now we add 10, 15, so that's 15, so that's 75. Is it? Let me just double check. So 15 times 5. Oops. It is 75, so we're good. So minus square root of 15 times square root of 3. Again, when you multiply square roots, you multiply the insides. So 15 times 3, we got 45. Okay. So we got 45. So now we're done multiplying the numerators. So now let's multiply the denominators now. So let's divide this. Let's perform our first distribution. Square root of 5 times square root of 5. That is the square root of 25. Because 5 times 5 is 25. Square root of 5 minus square root of 3. So that's minus square root of 15. Because when you multiply square roots, you multiply the inside. So 5 times 3, that's 15. Okay, so now let's perform our other operation here. Square root of 3 times square root of 5. That is, what is that? Positive square root of 15. You multiply the insides again. 5 times 3, that's 15. And square root of 3 minus square root of 3, so that's minus square root of 9. Okay. So now we have this. What do you notice about the square roots? What do you notice about the middle square roots? They will cancel out. Minus square root of 15 plus square root of 15, they cancel out. So now, let's see if we can simplify. Now, let's rewrite everything now. So we got square root of 75 minus 45. Oops, square root of 45. Now square root of 25, that's 5. Minus square root of 9 is 3. So we have square root of 75 minus square root of 45 divided by 2. Because 5 minus 3 is 2. Now, we're going to try and rewrite the inside. But because of time issues, the video is about to be over. We need to simplify the square root of 75. And we need to simplify that 45. But essentially right now, without any simplification done, you can consider this as your final answer, but because of time, I'm going to stop here.